Hi, and welcome to the VI Roadshow. I'm Brian Spears, Web Community Product Marketing Engineer at National Instruments, and I'm here at the Leaf Combustion Laboratory at Brigham Young University in Provo, Utah. I'm speaking today with Brent Pickett, graduate student in chemical engineering here at BYU. Tell us about the application. What is the purpose of the project you're working on?
The purpose of the project is basically determine the fundamental combustion of leaves in forest fires.
Okay, Brent, tell us a little bit about your application.
Our application is fairly simple. What we have here is it's a flat flame burner. It gives convective gases which will ignite this particular leaf or the many leaves. We can connect to this, we can measure a gas temperature of this convective flat flame burner. We can measure this temperature with this thermocouple here. We also have it on this mass balance, so we can measure the mass, we can measure the temperature, and we also have it hooked up to record video images of this combustion process. From this we can get ignition times, the time when it ignites, the flame duration. We can get a variety of data from this particular setup that we have. We usually set this thermocouple inside the leaf itself so we can get the temperature of the leaf at this during this process. Once this flat flame burner is in place, it'll stop right under the leaf, which will ignite the leaf. From this we can monitor from the mass balance, the temperature, and we'll also get these video images from LabVIEW. Turn it on. Slowly come in like a fire front, like a flame front. There's a little poppling that's semi-normal. You see it in different types of leaves burn differently. So then you see it burn in. It usually only takes 3 or 4, or probably like 30 seconds or so to be able to get the actual, all of the run. And then we're done. And then we can do multiple leaves for this particular application. And so basically to start this run, it's fairly simple. You just kind of hit a key, go ahead and hit begin, and then when you want to save your actual data that you have, we'll go ahead and hit, you can go ahead and do it. Go ahead and hit save file, and you see the temperature ramped up there. There's the bursting, bubbling leaves that you see. It'll be burning. And when you see that the flame is gone, we'll turn it off and then just hit end to stop it completely. When the ignition temperature, or when the ignition occurs, and you can see the leaf changes color a little bit. You can get the temperature. There's a big burst of light. It's kind of hard it's kind of hard to determine exactly when ignition occurs, but we try our best. We define it as the first sustained ignition that we see. We're probably starting to see the first little bits of it right here as it's burning. And I'm going to just kind of fast forward through this. And then here we're seeing part where we can see probably a near maximum flame height, and then we'll see the overall extinction of the leaves itself. And we're particularly interested in the volatiles region. This is just kind of an image of a side-by-side image of an IR camera versus the video images that we get. And you can see kind of the bursting that happens and the temperature drop that actually occurs while these how this is occurring. And so this is just because we have these video images, we're able to do this and just kind of pan them all together to kind of replay the whole image all over again. It's NI DAC. It's a NI 4351 PCI device.
And looks like you have an iMac device as well.
Yeah, the iMac device is a separate device. We run the video camera to this VCR basically, and the VCR is then connected through a coaxial type cable to the computer, which is
expand on that?
Yeah, I'll get it here.
Okay.
It's a PCI 1411 device. We needed kind of a high resolution with regards to time for these to be able to get an accurate time to ignition. And that's why the 18 to 19 hertz is actually helpful for us. That's kind of the reason why we went with the National Instruments, because it could do all of this. It could combine all of these, the temperatures, the mass, the video images for all of these programs, and just kind of combine them into one. And it makes it really easy for us for the data analysis. This will help eventually in forest fire models that can be used to predict the spread rate in these fire models. That's basically the overall. We're trying to find out more physics of what is actually happens in this leaf combustion.